Welcome to my Advanced Database Management System course. In this section, we discuss about indexing and query optimization, types of indexes, benefits of indexing, query optimization techniques for query optimization. Let's enjoy. Indexing and query optimization are essential techniques used to improve the performance of database systems by speeding up data retrieval and query processing. Here's an overview of indexing and query optimization. Indexing. What is an index? An index is a data structure associated with a database table that allows for efficient retrieval of data based on certain columns or expressions. Indexes provide a quick lookup mechanism, similar to the index of a book, allowing the database to locate specific rows quickly without scanning the entire table. Types of indexes. B-tree index, the most common type of index used in database systems. It stores keys in sorted order, allowing for efficient range queries and equality searches. Hash index uses a hash function to map keys to index entries, providing constant time lookup for equality searches but not supporting range queries. Bitmap index, suitable for columns with low cardinality, where each bit in the index represents the presence or absence of a value. Full text index, designed for efficient text searches, supporting operations such as word searches and phrase searches. Spatial index, optimized for spatial data types, enabling efficient retrieval of spatial objects based on their geometric properties. Creating indexes. Indexes can be created using SQL commands, such as create index. You specify the table and column S to be indexed, and the database system creates the index accordingly. Benefits of indexing. Improved query performance. Indexes speed up data retrieval operations, especially for columns frequently used in search conditions or join predicates. Enhanced data integrity. Unique indexes enforce uniqueness constraints, preventing duplicate values in indexed columns. Support for constraints. Indexes can be used to enforce primary key, unique key, and foreign key constraints. What is query optimization? Query optimization is the process of improving the performance of database queries by selecting efficient execution plans. The goal is to minimize query execution time, reduce resource consumption, and improve overall system efficiency. Query execution plans. A query execution plan is a sequence of operations performed by the database system to retrieve and process data requested by a query. The optimizer generates multiple execution plans and selects the one with the lowest cost based on factors such as access methods, join algorithms, and index usage. Techniques for query optimization. Cost-based optimization uses statistical information and cost models to estimate the cost of executing different query plans and selects the plan with the lowest estimated cost. Query rewriting transforms the original query into an equivalent form that can be executed more efficiently. Techniques include predicate pushdown, join reordering, and subquery optimization. Index usage identifies and selects appropriate indexes to access data efficiently. The optimizer considers index selectivity, cardinality, and access path options. For example, index scans, index seeks. Join optimization determines the most efficient join order and join algorithms. For example, nested loop join, hash join, merge join, based on the size of the tables, join conditions, and available indexes. Parallel execution executes queries in parallel across multiple CPU cores or nodes to exploit parallelism and reduce query execution time. Monitoring and tuning. Query performance should be regularly monitored using tools such as database performance monitors and profiler tools. Performance bottlenecks can be identified and query optimization techniques can be applied to address them. This includes creating or modifying indexes, rewriting queries, or adjusting database configuration parameters. Effective indexing and query optimization play a crucial role in improving database performance, reducing query response times, and enhancing overall system scalability and efficiency. By utilizing appropriate indexing strategies and optimizing query execution plans, database administrators can ensure optimal performance and responsiveness of their database systems. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson.